guys, today we're going to do 2-6 families of functions, part 2. Our objective will be to analyze transformations of functions, and there are many sets of functions called families which we know about, and each function is a transformation of a special function called the parent function. So now we're going to have A and B be colors as well. We already know that D was our vertical shift, C was our horizontal shift. A is now going to be the vertical stretch or shrink, and B is going to be the horizontal stretch or shrink. B, however, we're not going to get too much into horizontal stretches and shrinks, but we will use reflecting for B. And what is a reflection? A reflection flips the graph of a function across a line, such as the x or y axis. Each point on the graph of the reflected function is the same distance from the line of reflection as it is as its corresponding point on the graph of the original function. When we reflect a graph on the y-axis, the x values change signs and the y values stay the same. So y-axis, x values change. When you reflect a graph on the x-axis, x values stay the same and y values change. Think about it. If we are flipping over, getting our mirror image of our x-axis, our y values are changing. And vice versa for the y-axis. So for a function f of x, the reflection in the y-axis is f of negative x. So y-axis is negative x. And that's also going to correspond when b is negative. Then we have a reflection in the x-axis is the opposite of f of x. So that would be taking the opposite of the entire function rather than plugging in the opposite of x. Problem 3, reflecting a function algebraically. Let g of x be the reflection of f of x is equal to 3x plus 3 in the y-axis. Y-axis, we have to remember, is b. So we will plug in f of negative x. What is the function rule for g of x? So g of x is going to be equal to f of negative x. So g of x will be equal to 3 times negative x plus 3. So g of x is equal to negative 3x plus 3. Now we have a vertical stretch. And a vertical stretch multiplies all of our y values of a function by the same factor that is greater than 1. A vertical compression or shrink reduces all y values of a function by the same factor between 0 and 1. So we're not talking about negatives because negatives we saw before is reflecting. So we just have to see if it's a fraction or a decimal, we're going to get smaller. If it's bigger than 1, we are going to get bigger. And this is for when we see A. You can see on the right side of our graph, we have A, f of x is in our red. And this is stretched. So it's longer up and down, where we have blue, which was just f of x. And then we have green, which is smaller than blue. Stretching and compressing. We have to remember that we are affecting our y coordinates. So at the table of the right represents a function f of x. What are corresponding values of g of x and possible graphs for the transformation of g of x is equal to 3 times f of x. If it's 3 times f of x, this means A. So we have a vertical stretch. So we are going to multiply our y coordinates by 3. We're going to keep our x coordinates. And now it's going to be 3 times f of x. So 3 times 2, which is 6. Negative 2, 6, 0. Negative 3 times 3, negative 9. 3 times 1, 3. 5. 3 times negative 2, negative 6. So this would be g of x. Please make sure you have all of this information written down. This is a summary of all of our transformations of f of x. Vertical translation, if we add, we go up. If we subtract, we go down. Horizontal translation, if we subtract, we go to the left. If we subtract, we go to the right. If we add, we go to the left. Because this was opposite. Then vertical stretches and shrinks. We stretch if A is bigger than 1, and we shrink if A is between 0 and 1. Then we have a reflection, which deals with negatives of A and B. So if we take the opposite of f of x, that means we are taking the opposite of our y values, which means we are reflecting our x-axis. So this is when A is negative. And if B is negative, we are taking the opposite of our x values, which means we are reflecting over the y-axis. Problem 5, combining transformations. The graph g of x is the graph of f of x is equal to 4x, compressed vertically by the factor of 1/2, and then reflected in the y-axis. What is the function rule for g of x? So if we are compressed vertically, that means a is equal to 1/2. And remember, that's our transformations equation. So a is equal to 1/2. And if we reflect in the y-axis, that means we are taking the opposite of our x values. So this means b is negative. So now we're going to apply that to f of x. So 1/2 f of negative x. Which means we are going to have g of x equal, instead of f of x, we're going to write 4x. 1/2 times 4 of negative x. 1/2 of 4 is 2 times negative x is negative 2x. Would be g of x. Oh, sorry. Then, what transformations change the graph of f of x to the graph of g of x? So now we have g of x, which is our end transformations, and we want to know what we did to it. We did to f of x to get to there. So we want to see where 2x squared fits in here. So we have 6, which we could break up into 2x squared times 3 minus 1. And now since we have this 2x squared, that was f of x. So that really means 3 times f of x minus 1. So what were the transformations that we did here? We stretched vertically by a factor of 3, and we move down 1. For the you try it, please describe the transformations made to f of x here in number 6.